Welcome to a video on the trigonometric functions in terms of the angles of rotation. So if we consider the following angle, let's call this angle theta from here to here, in standard position that intersects a circle with radius r at the point xy, you can think of the radius as the hypotenuse of the triangle formed by dropping this perpendicular to the x-axis. And because of the relationship between the three sides of a right triangle based upon the Pythagorean theorem, we can state that r squared is equal to x squared plus y squared, again r being the hypotenuse, so r would equal the principal square root of x squared plus y squared. So using this right triangle for our angle theta, which is actually called a reference triangle, we can define the trigonometric functions in terms of x, y, and r. Again, just keep in mind that if this is our angle theta and this is our triangle, y would actually be the opposite side. R, again, is the hypotenuse, which leaves x to be the adjacent side. So we're going to state these in terms of x, y, and r, but essentially we are using the same thing we did in the last video where sine theta would be opposite over hypotenuse, but now the opposite side is y and the hypotenuse is r. Cosine theta, instead of stating it as adjacent over hypotenuse, is now x over r, and tangent theta, instead of stating it as opposite over adjacent, would now be y over x. And then just remember that cosecant theta is the reciprocal of sine theta, so instead of y over r, we have r over y. And for secant theta, which is the reciprocal of cosine theta, we have r over x instead of x over r. And again, cotangent theta is the reciprocal of tangent theta, so we have x over y instead of y over x. So using this acronym SOHCAHTOA will also help you remember these. You just have to remember that when we sketch our triangle, we use x, y's, and r's instead. Now if the terminal sides of the angles do not fall in the first quadrant, we need to pay close attention to the sign of x and y, because the sign of the x and y will affect the sign of the trigonometric functions. We know that both x and y are positive in the first quadrant, so all trigonometric functions will be positive, but over in the second quadrant, the x is negative and the y is positive. Of course, this will affect the sign of cosine and tangent and their reciprocals. In the third quadrant, both x and y are negative, and this will affect sine and cosine and their reciprocals. And then in quadrant 4, the x-coordinate is positive, the y is negative, so this will affect the sign of the sine function as well as the tangent function and their reciprocals. So here's an example of it. Consider the terminal side of the angle in standard position that passes through the point 8, negative 6. Find the values of the 6 trigonometric functions. So first we would plot our angle in standard position, which would be this. But remember, to form the reference triangle that we're going to use to find these values, we drop a perpendicular to the closest x-axis, which is here. So we're actually going to use this angle to determine the values of the trigonometric functions for this angle. So we can see that the x-coordinate is 8, so this distance here would be 8. And the y-coordinate is negative 6, so even though we think of distance as positive, we are going to use a signed integer to represent this as negative 6. Now the next thing we should recognize is the hypotenuse is missing, which we will call r. So remember from the previous screen, r is equal to the square root of x squared plus y squared. Let's find that. So we have 64 plus 36, which equals the square root of 100. So r is equal to 10, and r is always positive. That's all the information we need to find the 6 trigonometric functions for this angle. Sine theta would be y over r, or negative 6 over 10, which simplifies to negative 3/5. Cosine theta would be x over r, which would be 8 over 10, or 4/5. And tangent theta is y over x, negative 6/8, which simplifies to negative 3/4. once we have these, we can just identify the reciprocal functions. So cosecant theta would be negative 5/3, secant theta would be 5/4, and cotangent theta would be negative 4/3. So just pay close attention to the sign of x and y, and it's pretty much the same as the last video.